Okay, good afternoon, everybody. So, we'll start today a very important topic in classical algebra, actually, theory of equations. So, I will give you some idea about some important techniques or problems, how to solve the problems of theory of equations. And let us start with the fundamental theorem of algebra. What is the fundamental theorem of classical algebra? If I talk about every algebraic equation has a root, real or complex. So let us start the session with this fundamental theorem of classical algebra. So I will go to the first problem. If PQR belongs to the real numbers and x cube plus px square plus qx plus r equal to 0 has three real roots, because it's a cubic equation, and also from the fundamental theorem of algebra, every algebraic equation has a root, real or complex. So, and the third degree equation has at most, it has three roots. And also I want to point out that any odd degree equation must have at least one real root, because imaginary roots always occur in pair. Now here it is talking about three real roots. Then you have to find which option is correct. P square less than 3q. Option 2, p square less than equal to 3q. Option 3, p square greater equal to 3q. And the fourth option is none of this. So this none of this is a very dangerous option. You have to be very careful if your option is having none of this. So it might happen that you have an option of none of this. Okay. So this you have to be very careful while you are preparing for JEE mains, advanced or any competitive exams in all India level. So first of all, to solve this problem, I will remind you about Rolle's theorem for polynomials. So what is Rolle's theorem for polynomials? Let fx be a polynomial with real coefficients between two consecutive real roots of the equation fx equal to 0. There is at least one real root of the equation f prime x equal to 0. So this is the version of the Rolle's theorem in polynomials, and you have a main Rolle's theorem in mean value theorems that you will see later on. But what is the polynomial version of the Rolle's theorem? If x be a polynomial with real coefficients, it must have real coefficients. Then between two consecutive real roots of the equation fx equal to 0, there is at least one real root of the equation f prime x equal, that is the derived polynomial. This is called the derived polynomial f prime x equal to 0. So between two real roots, that means roots of fx is separated by roots of a prime x. So if this is the root for fx, alpha and beta, then this is the root for alpha, this is alpha and beta, this is gamma. So gamma is the root of the derived polynomial. This is the derived polynomial f prime x equal to 0. So roots of fx is separated by f prime x. Okay, roots of fx are separated by the roots of alpha and beta. So that is the main concept and very important concept. I will use this. So it is said that this equation, this cubic equation has three roots. So let us find the derived polynomial. What is the derived polynomial? 3x squared plus 2px plus q. Okay, this is the derived polynomial. This is equal to 0. F prime x equal to 0 is the derived polynomial function. It's a derived equation, and it must have two equal roots. It must have two real roots. It must have two real roots, because your cubic equation has three real roots. So derived polynomial must have two real roots. Two real roots. It must have two real roots. So if it has two real roots, then the discriminant must be 0. So what is the discriminant of the derived one? 2p squared, b square minus 4ac must be greater or equal to 0. 4 into 3 into q greater or equal to 0. So that will give you p square greater or equal to 3q. p square greater equal to 3q. For real roots, we know that b square minus 4ac must be greater than or equal to 0. Okay, so that is the theory. So what is your option? Your option is C, or third option, p square greater equal to 3q. So you are using the concept of real roots. So if the polynomial third degree polynomial has 3 real roots, its derived polynomial must have 2 real roots. Okay, because using the statement of the Rolle's theorem, because the roots of the polynomial are separated, or roots of the polynomials are separated by the derived polynomial equation, or between two real roots of derived polynomial there must be a root of uh, between two real roots of the main polynomial equation there is a real root of f prime x. So that is the thing. So this is the fx. So between two real roots there must be a real root of derived polynomial. So this blue curve is the derived polynomial. So look at that, the roots of the derived polynomial, it must be real, otherwise it cannot happen. So these real roots are separating the real roots of fx, separating the real, that is the main concept behind this question. So there will be more problems on that in the question paper, you can solve that. So let's go to number 2. Number 2 is the least number of imaginary roots of the equation x to the power 9 minus x to the power 5 plus x to the power 4 plus x squared plus 1 equal to 0. You want least number of imaginary roots of this equation 2, 8, 4, 6. These are the options. Now I will use Descartes' rule of sign. I will use Descartes for finding the rough estimation of the real and imaginary roots. So Descartes' rule is a fantastic rule in theory of equations to finding the rough estimations of real and imaginary roots. Let us see. So Descartes' rule of sign, the number of positive roots of an equation fx equal to 0 with real coefficients doesn't exceed the number of variations of signs in the sequence of the coefficients of fx, and if it is less, it is less by an even number. That is the Descartes' rule of sign for positive real roots. You can write the same rule for the negative. The number of, once again I repeat, the number of positive roots of an equation fx equal to 0 with real coefficient doesn't exceed the number of variations of sign in the sequence of the coefficients of fx, and if it less, it is less by an even number. It is less by an even number. So it's same happening for the negative root of the number of negative roots of an equation f minus x equal to 0. In that case, you have to replace x by minus x. Okay, that's it. So let us find the positive roots first. So look at that. What are the variations? Plus this is fx. Suppose this is fx. This equation is fx. So this is plus, minus, plus, 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 positive. So how many variations are there? You see there are 2 variations. So number of positive roots of the equations are 2 or 0. If it is less by an even number, look at the last line of the Descartes. If it is less by an even number, so number of positive roots is 2 or 0. You are subtracting the smallest positive, so smallest even number 2. So number of positive roots is either 2 or 0. Let us find out the negative roots. How many negative roots? So let us replace x by minus x. So that's gonna be, it will be minus, plus, plus, positive, positive, and positive. So there is only one variation of sign in case of f of minus x. So there is only one negative root. How many negative roots? One negative roots. Okay, one negative roots. Only one negative roots you have. So how many real roots? Either 3 or 1. The number of real roots equal to 3 or 1. 3 or 1, 2 plus 1 3, and 0 plus 1 1. So either 3 real roots or 1, exactly 1 real roots. So the degree of the polynomial is 9, so it must have 9 roots. So other roots must be complex. So the complex roots would be 6 imaginary roots. Imaginary roots. So your imaginary roots will be 6 or 8. Okay, so least number of imaginary roots will be 6. Least number of imaginary roots would be 6. Okay, so your option will be last option, D or 4. Fourth option is the answer. 6. Least number of imaginary roots will be 6. So that will, Descartes rule, give you the rough estimation of the roots. Okay, let's move to number 3. Suppose a plus b plus c and a minus b plus c are positive and c less than 0, then the equation, the quadratic polynomial ax square plus bx plus c equal to 0 has exactly one root lying between -1 and 1, both the roots lying between -1 and 1, no root lying between -1 and 1, and last option is nothing definite can be said about the roots. So this is also very good problem. Before that, let me talk about one very important concept that is sometimes called Bolzano's theorem. Let fx be a polynomial, and you know that polynomials are always continuous and differentiable. Polynomial with real coefficients. If alpha beta be two distinct real numbers such that f alpha and f beta are of opposite signs, then the equation fx equal to 0 has at least one real root between alpha and beta. So if you draw the diagram, so suppose this is the polynomial, look at that. So this suppose alpha and this suppose beta. So your f alpha is positive, look at that, this height is your f alpha, the value at alpha, and this is beta, sorry, this is beta. So your f beta is negative. So between, if f alpha and f beta are of opposite sign, so in this case you have f alpha positive, f beta negative, so there is at least one root, look at that, the root, this is the root, the point of intersection with the x-axis, that will give you the value of the root. So there must be a root, at least one root between alpha and beta. So if this will happen if f alpha and f beta are opposite signs. Okay, and this is called Bolzano's theorem also sometimes. And suppose the case can be this type. Yeah, in this case your f alpha is negative and f beta is positive. So alpha and beta are opposite signs, so there exists at least one root between alpha and beta, and the root is c. C is the root where it cuts the x-axis. That is the concept of the root. So this is very important theorem. So I will use this theorem everywhere in theory of equation. You have to remember this type of theorems. So a plus b plus c and a minus b plus c are positive and c less than 0. Okay, and the fx is actually, let me write your fx equal to ax squared plus bx plus c. Okay, and what is your f1? What is your f1? F1 is a plus b plus c. F1 is a plus b plus c, and that is positive. Look at that, because it is given in the question, a plus b plus c is positive, because in the options you just guess an idea about 1 minus 1. So 1 minus 1 0, these are the values, you can check these values. And f1 is a plus b plus c greater than 0. And what about your f0? What about your f0? F0 will be, it's gonna be c, and c is less than 0. So look at that, f1 the value is positive, f1 is positive, f0 is negative. So there must exist a root between 0 and 1. 0 and 1, there must exist, there exists a root in 0 and 1. 0 and open interval 0 and 1 having a root, having a root. Once again, let us check f minus 1. Let us find the value at f minus 1. What is f minus 1? F minus 1 will be a minus b plus c, and that is positive. Okay, f minus 1 is positive, and f0 is again c, it is negative. So again, f minus 1 is positive, f0 is negative. So there must exist a root between minus 1 and 0. Okay, so one root between 0 and 1, another root between minus 1 and 0. One root lies between 0 and 1, another root lies between minus 1 and 0. So how many roots you have? Two real roots. You got two real roots because it has two real roots, degree 2. So look at the options. Exactly one root lying between minus 1 and 1, both the roots lying between minus 1 and 1. So this is your options, option 2. So this is a very good example of roots in the intervals. Okay, let's move to problem number 4. So problem number 4, the polynomial x to the power 7 plus x square plus 1 is divisible by, you have to find out, divisible by what it is divisible by which one of the polynomials. All are fifth degree polynomials. You have to choose the options. Now before that, this is little bit tricky problem. First of all, you check that whether if x to the power 7 is a 7 degree equation, it must have one real root. Let us test what is your f omega. Omega is a huge imaginary cube root of unity. Let us test for that. This is a very specific problem. Not in all problems you can test for omega, but let us try for some. After that, I will explain some theoretical explanation. If omega is omega to the power 7 omega squared plus 1. So omega to the power 7 is nothing but your omega cube, because omega to the power yeah, omega, it is omega, because omega to the power 6 is 1, because omega cube is 1, correct? So omega plus omega square plus 1, and that is equal to 0. So omega satisfies this equation, this polynomial equation. If you put in the polynomial equation fx, it will satisfy. So let this be fx. So it will satisfy the omega is a root of this polynomial clearly. So omega square is also a root of this polynomial, because if omega is a root, omega square must be there, because omega and omega square are conjugate to each other, and imaginary roots always occur in pair, that you know. Now I will explain two theorems. One is a remainder theorem. It is not required here. If a polynomial fx is divided by x minus alpha, the remainder is f alpha. This is a very important, and a factor theorem. If fx be a polynomial, then x minus alpha is a factor of fx if and only if f alpha equal to 0. That is, if alpha is a root of the polynomial, x minus alpha is a factor. If x minus alpha is a factor of the polynomial, f alpha is a root. So this is if and only if, necessary and sufficient condition. So remainder theorem, factor theorem. So I will use omega is the root of this polynomial. So x minus omega is a factor. X omega square is a root of this equation. So x minus omega square is a factor. So the factors are x minus omega square, and that is the, that can be reduced to x square plus x plus 1, because this polynomial will give you the roots, imaginary cube roots of unity. So if you divide, so let me write fx, let me write now fx equal to x squared. One of the factor, one of the polynomial is known to you, you don't know the other one. Let the other one be qx, let the other polynomial be qx. Now if you divide x to the power 7 plus x squared plus 1, if you divide x to the power 7 plus x squared plus 1 by this polynomial whose roots are omega and omega square, you will get the other part, you will get the another part, quotient. Your quotient will be the result, your quotient will be the required result, and I am giving you the result will be the first one. This is for hint, you can check your calculation. I'm not giving you the, you know the division, how to do the division, so that will give you. So look at the concept, I'm using factor theorem. First of all, you have to test for omega. If omega, certainly this is a very particular type of problem, because omega satisfies the equation, and so you naturally you got the answer that omega is a root of that equation, and also omega square is a root of that equation. So x minus omega is a factor of that equation. X minus omega square is also a factor of that equation. So naturally the product x minus omega and x minus omega square, both are factors, and if you multiply you will get x square plus x plus 1. So naturally if you have x square plus x plus 1, then fx can be written as fx, the polynomial, can be written as x square plus x plus 1 into qx. Qx is the polynomial, the rest polynomial, because it's a 7-degree polynomial. Qx must be of degree 5. So Qx can be obtained by the division algorithm. The quotient will give you the answer, and the answer will be the first one. So this is very important concept using factor theorem. Maybe you require remainder theorem. So these are all techniques of polynomials, theorem equations. Let's move to the next part. Next problem. This is also very important problem. If alpha, beta, gamma are the roots of the equation x cubed minus x squared minus 1 equal to 0, then the value of 1 plus alpha by 1 minus alpha plus 1 plus beta by 1 minus beta plus 1 plus gamma by 1 minus gamma is minus 5, minus 6, minus 7, minus 2. You have to choose the options. Now you see, you can easily check that alpha plus beta plus gamma is uh, you can easily check that alpha plus 1, and if you take alpha beta plus beta gamma plus gamma alpha, that will be 0 because there is no x term, and you have alpha beta gamma, that will be uh, plus 1. So these are the informations you have from the given equation, but this is not very helpful in the calculation of this part. If you calculate 1 plus alpha by 1 minus alpha, you look at that, the calculation is not so easy in this case, because this results will not so helpful, and during exams this will be very complicated term. If you then it will take so much of time that you cannot follow other problems, or you miss the other easy problems. So it's better to have some transformation rules. I will use a transformation rule that will help you to find out. And the rule is, look at that, you have a symmetric function type. You can write this given equation as summation 1 plus alpha by 1 minus alpha. That will give you the same meaning, that will provide you the same meaning, that is 1 plus alpha by 1 minus alpha. 1 plus this summation signifies 1 plus alpha by 1 minus alpha, 1 plus beta by 1 minus beta, 1 plus gamma by 1 minus gamma. So naturally it will give you the same idea. So you have 1 plus alpha by 1 minus alpha is a symmetric function. This is sometimes called symmetric functions. So I will use a transformation. Let y equal to 1 plus alpha by 1 minus alpha. Okay. Then if you take componendo dividendo, if you use your technique of componendo dividendo, it will give you alpha in terms of y. So alpha will be y minus 1 by y plus 1. Okay. This is your y. Now alpha is a root of this equation. Okay. So alpha must satisfy this equation. Alpha cube minus alpha square minus alpha 1 equal to 0. Now let us add a page here. Let me add. Yeah. So alpha cube minus alpha square minus 1 equal to 0. So what is your alpha? Alpha is y minus 1 by y plus 1. Let me substitute y minus 1 by y plus 1 whole cubed minus y minus 1 over y plus 1 whole squared minus 1 equal to 0. Okay. So if you simplify this cubic, I have simplified, so I'm giving you the result. You can check for simplification. It will give you y cubed plus 5y squared minus y plus 1 equal to 0. So it doesn't take so much of time because you can easily calculate this thing, but rather than it is a very complicated to solve this thing 1 plus alpha by 1 minus alpha, I will suggest this technique. So this is the cubic equation whose roots are because you have taken the transformation, whose roots are 1 by 1 plus alpha 1 minus alpha. So whose roots are actually let me show you the roots. You have taken the transformation this, whose roots are 1 plus alpha by 1 minus alpha, 1 plus beta by 1 plus beta 1 minus beta, and 1 plus gamma over 1 minus gamma. So these are the roots of this equation. So what is the sum of the roots? What is the sum of the roots? So summation 1 plus alpha by 1 minus alpha. Summation signifies 1 plus alpha by 1 minus alpha plus 1 plus beta by 1 minus beta plus 1 plus gamma by 1 minus gamma. So this summation equal to minus 5. Look at that. This is a minus 5 minus b by a, first one. So minus 5 is the answer. So I will suggest this process because this is more helpful in any type of problem of this. You can easily calculate rather than this crude calculations. So minus 5 is the answer. So 1 is the answer. Okay. This is your technique of, I'm using the technique of transformation. Transformation. Okay, everybody. So now next I will go to number 6. Okay, yeah. So number 6, if alpha beta are the roots of 375 x squared minus 25x minus 2 equal to 0 and Sn is alpha to the power n plus beta to the power n, then find the value of limit n goes to infinity summation over r equal to 1 to n Sr. So this looks like very complicated, but don't worry about that. This, some problems are looks complicated, but they will be simple. Always attempt the complicated problems, they will be simple, don't worry about that. So uh, let us find the sum of the roots. What is your sum of the roots? Alpha plus beta is 25 over 375, that's gonna be 1 by 15, right? 1 by 15. And what is your product? Product will be minus 2 by 375. Okay, that is your product of the roots. Now let me write this one. Limit n goes to infinity summation SR is SR. So I will write alpha to the power R, beta to the power R. Okay. So let me write this one here. Okay. Let me use the space here. So limit n goes to infinity summation R equal to 1 to n is R, and that's equal limit n goes to infinity summation r equal to 1 to n, it's alpha to the power r plus beta to the power r. Okay, according to the questions I'm writing. So now you take the summation first term will be 1, second 2, 3, etc. up to infinity because n goes to infinity. So I'm writing separately because you have a plus sign. So okay, split into two parts. So first part will be alpha, alpha squared, alpha cubed, etc. up to infinite terms plus beta plus beta squared, etc. up to infinite sum. So this is infinite GP, and alpha and beta must be less than 1 because you see the values of the sum is 1 by 15 and the product is minus 2 by 375. So mod value of alpha and beta must be less than 1. So if mod value is less than 1 and infinite, this is an infinite GP series. So infinite GP series, the sum is a over 1 by r, a over 1 minus r. This is if the common ratio is r. In this case your common ratio is alpha, that is alpha is multiplied with each term. Alpha is multiplied with each term. So you have alpha over 1 minus alpha, and in this case you have beta over 1 minus beta. Okay, alpha over 1 minus alpha and plus beta over 1 minus beta. So if you simplify these two values, provided that mod alpha and mod beta must be less than 1, that is, it is less than 1, otherwise you cannot apply the sum formula for infinite GP. So if you simplify the result, so that's gonna be alpha plus beta minus 2 alpha beta over 1 minus alpha plus beta plus alpha beta. Okay, and if you simplify, you know that you know all the values, and the answer will be 1 by 12. I'm just telling you the answer because I have calculated, so you can check the answer will be 1 by 12. So that is the technique. That means not only theory of equations, all the chapters may be related. You have a problem on series also in this case. So your answer will be 1 by 12, that is answer is B, 1 by 12, the second option. Okay, let's go to the next one. The seventh one is a very interesting problem. The equation 1 plus x by factorial 1 plus x square by factorial 2 etc xn by factorial n equal to 0 have a multiple root of order 2. Second option have a multiple root of order 3. Third option have a multiple root of order 4 and cannot have a multiple root. So these are talking about multiple roots. Let me tell you one thing. If fx equal to 0, fx is a polynomial. I am talking about a polynomial. These are all polynomial. So fx equal to 0 has a multiple root alpha, has a multiple root, has a multiple root of order r, then f prime x, that is the derived polynomial, f prime x is equal to 0 must have a multiple root of order r minus 1. So its multiple root will be decreased by order 1. So if fx has a multiple root of order r, multiple roots means double roots, that means alpha 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 r times, then f prime x equal to 0, that is the derived polynomial, must have a multiple root of order alpha 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 r minus 1 times. That is the concept. If x equal to 0 has a multiple root of order r, its derived polynomial must have a multiple root of order less than 1. So that is the concept. So let us suppose that equation having a multiple root. Let me assume that. Okay, I am assuming that this equation has a multiple root. So let me use fx equal to, I'm writing fx equal to 1 plus x by factorial 1 plus x squared by factorial 2 plus etc x to the power n by factorial n. Okay, and let alpha be the multiple root. Alpha be the multiple root. I'm not mentioning the order, that is not required. It may be 2, 3, whatever. I don't need that. Multiple root. Then if alpha equal to 0, if alpha is a root of the distribution, it must satisfy, and f prime alpha equal to 0. If it is a order 2, if multiple root of order 2, it must satisfy the first derivative. First derivative f prime alpha equal to 0. So what is the first derivative of, so you have you can write, it will satisfy. So you can write the first one, 1 plus alpha square by factorial 2 etc. The second last term will be alpha to the power n minus 1 by factorial n minus 1, and the last term would be alpha to the power n by factorial n equal to 0, and f prime. So if you differentiate this, it will 1, derivative of 1 will be 0, derivative of alpha will be 1, and the second alpha square derivative will be 2 alpha. So we can write this as 1 plus, it will come back as the same series, but only the last term would be alpha to the power n minus 1 by factorial n minus 1. Okay, so that's it, because if you differentiate the last term, it will be n alpha to the power n minus 1, and factorial n can be written as n factorial n minus 1. So this is the last term for the derivative part. So if you subtract these two, all the terms get cancelled, all the terms except this term. So you have, if you subtract this 1 minus 2, it will give you this, and that conclude that alpha must be 0. That is, 0 is a root of that equation. That is, the conclusion is that 0 is a root of the given polynomial equation. 0 is a root. But look at that. What is your given polynomial? 1 plus x by factorial 1. So f0 is not equal to 0. F0 is 1. It is not equal to 0. So 0 is not a root. So that is a contradiction. So it cannot have a multiple root. So your answer will be number 4. cannot have a multiple root. It cannot have a multiple root. So that is the proof by contradiction. So this type of contradiction is very helpful during exams. Okay, everybody. So that's all. I think I have a last part. Okay. So last questions we have. Yeah, this is the last question. This is similar to that result. Alpha to the power n. Yeah. Alpha beta are the roots of the equation x squared minus 6x minus 2 equal to 0 with alpha greater than beta. Again, the same thing, we have solved this problem, but this problem came in very recent JEE mains question. An is alpha to the power n minus beta to the power n for n greater or equal to 1. Then the value of this. So alpha beta alpha will satisfy the equation. First of all, alpha square minus 6 alpha minus 2 equal to 0, and beta squared minus 6 beta minus 2 equal to 0. So alpha beta satisfies both the equation, this equation, because they are the roots. And now what I'm doing, I am multiplying both the equation. This is the first one by alpha to the power 8. So if I multiply with alpha to the power 8, that will be alpha to the power 10. Sorry, it will be 10. Yeah, yeah. So let me, okay, alpha to the power 10 minus 6 alpha to the power 9. Okay, let me write in a very fair space. Yeah. So what I'm doing, what is your equation? Alpha square minus 6 alpha minus 2 equal to 0, and beta square minus 6 beta minus 2 equal to 0. So if I multiply with alpha to the power 8 and the second one by beta to the power 8, so it's gonna be 10 minus 6 alpha to the power 9 minus 2 alpha to the power 8 equal to 0, beta to the power 10 minus 6 beta to the power 9 minus 2 beta to the power 8. Okay, so if you subtract this alpha to the power, subtracting 1 2 from 1, alpha to the power 10 minus beta to the power 10 minus 6 alpha to the power 9 minus beta to the power 9, and that is equal to 2 alpha to the power 8 minus beta to the power 8. So this is after subtractions. Okay. Okay. So, and this alpha to the power 10 minus beta to the power 10 is, look at that, an. An is alpha to the power n minus beta to the power n. So it's gonna be a10 minus 6a9 equal to 2a8, and that is equal to, you want, what do you want? You want a10 minus 2a8 by 2a9. So you can easily calculate a10 minus 2a8, sorry, not power, I have written the power, not power, a8 suffix equal to 6a9. So that's gonna be, the final result will be a10 minus 28 over 2a9. So that's gonna be 3. So 3 is the answer, everybody. So it's 3, number 3. Okay, then the value of this is number 3. Okay, everybody. So that's all for today. I have this beautiful problems of some good techniques, good theorems I have compiled for your understanding, better understanding. So these things will be helpful, very, very helpful in mains and advanced. And remember, always remember the important theorems for while you are solving the problems of theoretical equation. That's all for today. Thank you, all of you.